Hi everybody, I hope all of you are doing great. Before getting right into the lecture itself, I would request you to please support the channel and press that subscribe button because we are getting near to 450 subscribers and I would really appreciate your support, right? The problem we're going to solve today is called box stacking problem. It is a very underrated problem. It might look like it is a very difficult problem, but when we analyze this problem more and when we relate it to the previous problems we have solved in this dynamic programming series, it will of course become very easy to understand, right? So let us read the problem and understand. And before getting into this problem, I would like to tell you that this is a follow-up problem of longest decreasing subsequence itself. It is going to be the last problem in the series of this longest decreasing subsequence problem. So please, I request you to watch the previous problems. Like before this, we learned about dynamic programming, we learned about longest decreasing subsequence, we solved some other, you can say, follow problems on longest decreasing subsequence itself. So please satisfy the prerequisites first and then only watch this video. Only then you will be able to fully understand what we are going to do in this problem. Let's get right into it. Box stacking problem. Okay, you are given a set of n types of rectangular 3D boxes. N types of rectangular 3D boxes are given to us, where ith box has a height h, width w, length l. Rectangular box, right? Or you can say by box we mean a cuboid, right? So height, width and length are given to us for every one of those boxes. Your task is to create a stack of the boxes which is as tall as possible, but you can only stack a box on top of another if the dimensions of the 2D base of the lower box are each strictly larger than those of the 2D base of the higher box, right? And of course, you can rotate the box. Like, we'll of course read more about this problem. Let us first analyze this much part, what they have said in this line itself, right? This much line. Let us analyze this on board itself. So as you can see in this diagram, we are stacking the boxes on top of each other and the constraints are given to us. Of course, we have to ensure that we are able to make the maximum height. This is the main thing. This is the focus of the problem. You have to give the maximum height you will be able to form if you are able to stack the boxes on top of each other, and you can only keep a box on top of another box if you can see these are the dimensions of this box, right? This is the you can say height of this box. This is, I can say, this is the width, or the I can say this is the length, right? Can you see this is the, you can say, surface on which I'm going to place this box on, right? And if I want to place this box on this surface, the above surface, I do not care about height right now. If I want to place this box on this surface, can you see that if this is W1 L1 and this is, let's say, W2 and this is L2, so W1 should be strictly greater than W2 and L1 should be strictly greater than L2. This is given in the question, right? And yeah, this is exactly the same thing, right? So of course, if width is smaller of W2, then only I'll be able to accommodate this box in terms of width, and length should also be smaller so that I can accommodate this box. Height is of course independent because we are placing the box on top of each other. The only constraint they are giving us is the constraint on dimensions. That dimensions should be strictly smaller of a box you want to keep on another box, right? But a question arises, why are they talking about dimensions? I can also say, you can definitely say, Rohan, can we do something like this, that if the bottom box is having more area than the top box, then also we can place that. This is also, instead of talking about dimensions, can I simply say this area of 1 should be smaller, like of course greater than area of 2, then only I can place 2 on top of 1. No, my friend, I cannot say. I cannot compare these in terms of area. Why? Let us analyze. ध्यान से देखो यार. Full focus. This, let's say, these are the boxes we are having. This box is having a lot of, you can say area, right? But of course, this box is having smaller area than this box. Let's say L1. This is L1, and let's say this is L2. This is W1. This dimension is W1, and let's say this dimension is W2. We can definitely analyze from this that L1 is very big than L2. That is of course understandable. But can you see here that W1 is smaller than W2? And if this is the case, and if I try to place this box like this, I'll not be able to place the box like this, because this box will, of course, is, you can see it is getting overflown from this area. You can see this is getting extra areas, right? So that is why they are not giving us the constraint on areas. That is why they are giving a constraint on only the dimensions of the box. That width of the lower box should be strictly larger than the width of the upper box. length of the lower box should be strictly larger than the length of the upper box. I hope this much question is clear, and we have to of course stack the box on top of each other, right? Let us read the problem statement more, and let's understand what they are trying to say. Of course, you can rotate a box so that any side functions as its base. Okay, this is interesting. It is also allowable to use multiple instances of the same type of box. Your task is to complete the function maxHeight, which returns the height of the highest possible stack so formed, right? Now they are saying what? They're giving you n types of boxes, and they are telling you that you can rotate the block. You can rotate the boxes, and you can use multiple instances of the same type of box. Let's analyze this on board and let's understand what they're trying to say. So here I have drawn some kind of a diagram, and you can, from this diagram, you can analyze that if this is the box originally given to me, height is 5, width is 6, and length is 8. Definitely this is the original box which is given to me. Can I say I can, rotate this box? How many rotations are possible? Of course, I can rotate this box and I can make 6 as the height of the box, right? Then width and length would be like whatever, right? So you can see whatever the remaining thing is. So 6 is now the height. I can say I can treat 8 as the height as well. I have rotated this box one more time and I'm seeing that now 8 is the height, right? So I've got these rotations, right? You might argue with me that if 6, 5 and 8 is a rotation, can I say height is equal to 6, width is equal to 8, length is equal to 5 is also a rotation? Definitely, my friend, it is a rotation. Definitely. You are saying that height is 6. Okay. But I'll swap these dimensions. Instead of writing this, I'm writing like this. But I am saying that this is a valid rotation. But why do you want to do this kind of rotation? What I'm trying to say here, what I'm trying to prove here, that if you want to maximize the height of the boxes, if you want to maximize the height of the boxes and you want to stack the boxes on top of each other, you will, of course, use a standard kind of dimensions. Like look at this, let's look at this example. So for example, this is the box I'm having, right? Let's say this is the box I'm having, right? Or let's take this box as an example only. So if these are the boxes I'm having, right? Why would I maximize the width? If I maximize the width, if I maximize the width, can I put this box on top of this box? No. If I maximize the width of the box, I'll not be able to put. So what I'm trying to say that, of course, if we are having 3 variables, there are total 6 ways to arrange these 3 variables. If we are having A, B and C, I can, of course, say A, C and B, A and C, B, C and A, C, A and B, C, B and A. Yes, my friend, definitely you can of course arrange 3 pair of, you can say a trio of variables in these kinds of situations. But what I'm trying to say here is that if you want to rotate the boxes, and you want to find out the different configurations of rotations such that you are trying to maximize your height, one box will only be able to rotate in 3 possible, you can say, rotations. Why? You can see I am standardizing here. I'm standardizing that length will always be bigger than width. Length will always be bigger than width. Length will always be bigger than width. And if I ensure this kind of behavior, I will ensure that boxes can be stacked on top of each other, and that will be done. Of course, same the instance of this box, it can be or cannot be done that instead of this box can be placed on one another. But this is for sure that I am removing extra boxes from my checklist. Of course, do I want to consider this box? No, because this is a box which is having similar dimensions to this box. And if this box is representing this box, why do I want this box here? Correct. So I am removing the extra boxes. Of course, there are 6 possibilities. I am only considering the 3 possibilities. Why? Because height I am, choosing differently. Like every box, like every rotation might have a different kind of height. But width and length, right? If let's say this is the box I'm having. Let's say 5. Let's say this is the height. This is the width and this is the length. This is the box. And if I just rotate this box like this, you can say length becomes the width and width becomes the length. Can I say the box is remaining the same only, right? I have just swapped the width and length. I don't want to do that because that will create extra boxes for me, right? That will of course increase my space complexity as well, and that will unnecessarily, I'll be considering, you can say, extra boxes. this box is getting represented by this box, like this particular box is getting represented by this box only. Why do I want to swap W and L, right? So to get the rotations, to get the different rotations of boxes, what I'm trying to say, and to get unique rotations of boxes, that's what I'm trying to say. If we want to get the unique rotations, I will take height one by one as three different, you can say, dimensions. First of all, height will be whatever height is given to me. Then height will become the length. Then height will become the width. Correct? Width, on the other hand, it will be minimum of the remaining one. So it will be minimum of what? Here it will be minimum of length and width. Width will become minimum of length and height here. Width will become minimum of, you can say in a way, you can say, I would say length and height, right? I'm not sorry, here I have to write height and width, here I have to write length and height. And here definitely height will become what? Height will simply become maximum of length and width, maximum of height and width, maximum of length and height. And this is how we are going to obtain all the unique rotations of the boxes. Is this clear? Height, I'll be treating everybody one by one. And for the rest of the dimensions, width ke liye, height is given to me h. Remaining dimensions are L and W. The minimum of both will be the width for this particular configuration of box. For this particular configuration of box, min of this, max of this. L will be height. For this particular configuration of box, min of this, max of this, W will be. So I hope that it is clear that how we are rotating the boxes and how we are able to get different, you can say, rotations, unique rotations of a box itself, right? Now let us try to analyze this problem more, and let's try to understand how we are able to, how we are going to approach the, you can say, problem statement itself. So let us say these are the dimensions which is given to me, and according to these dimensions, these are the types of boxes they are giving me, right? Of course, the first thing I'm going to do, I'm going to get different configuration of every box, right? So here I'm going to write the height of the configuration, here I'm going to write the width, here I'm going to write the length, correct? Okay, so let us write this. Just give me a second. Let us quickly do it. Okay, now 4 4 can act as a height for this box. I'm just looking at this box right now. 4 can act as height. Width will be minimum of both of these two, so 6. Length will be maximum of both of these two, it is 7. This is one configuration. Now in this same box, 6 will act as the height. 6 is the height. Width will be minimum of the remaining ones, it will be 4. Length will be what? Length will be, you can say, maximum of both of the remaining ones. Of course, 6 I've used as the height, so remaining ones are 4 and 7. So 7 will be the length. If 7 acts as the height, can I simply directly write here that width will be 4 and length will be 6? Right, okay, okay. Let's talk about the configurations of this box. 1 is a, you can say, height, so 2 and 3 are the remaining ones. 2 is minimum, 2 and 3, 2 is minimum, 3 is maximum, okay. 2 is the one, so 1 and 3 I can definitely write here. Minimum of remaining, maximum of remaining. 3 is the one, 1 and 2 I can write here. Minimum of remaining, maximum of remaining, right? Okay, no issues. ध्यान से देखना. So let me consider this box right now. I'll of course, remove this box because it will unnecessarily make this test case very large. So 4, 5, 6. 4 is the height I'm treating as the first configuration. Okay. 5 will be the, you can say, width, right? And 6 will become the length, right? Maximum of length, minimum will be the width. All right, no issues. Let's say I'll write here, let's choose 5 as the height now. 4 and 6 I can write here. Let's choose 6 as the height. 4 and 5 I can write here. Correct. So what I have actually done here now, I've actually created this kind of, you can say, situation where I'm having different boxes. Now these are the different and unique boxes I'm having now. Correct. Now if I want to stack boxes on top of each other, can I in a generalized form say that the box in a generalized form, right? Can I say that the box having larger area can stay behind the box of the smaller area, right? Of course, we discussed here that, I am not going to place a box only on the basis of the area. But can I say area is one of the, you can say, factors which can affect this, correct? So let me quickly find out all the areas of all these boxes according to your length and width, right? Length and width is of course the surface area of the top portion on which we have to place another box, right? Let's quickly write the areas. So what I've done here, I've calculated the areas of all the boxes, and these are the areas which I've written here on the basis of their width and length. Okay, correct. Now the next step I'm going to do is, the first step was getting all the boxes. These are all the types of boxes I've got. The next step is, of course, on the basis of their areas, sort them. On the basis of their areas, sort them. So the smaller area, this 2 I think is the smaller area, it will go on top, and let's say 42 will come here. Okay, this is set now. Let's say 3 will go on here. Let's say 3 comes, this box of area 3 comes here. I'm sorting them on the basis of their areas only, right? Let's say 6 comes here, right? All right. Now I think, yeah, 24 should come here. I'm just sorting them one by one. Just give me some time. So let's say 20 of course has to come here, right? And then of course 24 will come here. Okay, no issues. 24 will definitely come here. And now what I'm going to do is 30 will definitely come here. Before 30 of course 28 will come, so I'll remove both of these two, and I think 24 should also come here, and 28, and now I think 32 and 40. Okay, I hope that this is clear, that I have sorted all the boxes on the basis of their base area, right? Base area means that whatever area like we are trying to put a box on, right? Now let us simplify this problem a little. Full focus के साथ देखना है. Here I'm going to write something, some information I'm going to write. What is that information I'm going to write? Let us analyze. Here I'm going to write some information. Let's analyze what information I'm going to write here. I've sorted. This is the second step I've done. Sorting is done on the basis of area. That is good. Good. Now what I'm going to fill this column with? This column will be filled, and we are trying to do something related to DP here, related to longest increasing subsequence. What is the longest increasing subsequence? Let's see. What do I mean by that? Can I say that, if this box wants to go under another box, these are the boxes. This box with a bigger base area can potentially go under, yes or no, right? So what I'm going to do, if this first box acts as the base box, what is the length they are able to make? I can only make which is a box of length 2, right? So height will be 2 only, correct? Sorry, height will, according to the height will be 3 only, correct? Okay, now I don't care about the area. Let us look at this more closely. So don't worry, if it is not clear, it will get clear. If this particular box wants to go below some boxes, what is the best boxes I can, what is the best height I can get on all the boxes like below which I can come? Can this particular box come under this box? You can of course imagine, right? These are not strictly smaller. One is not strictly smaller than this. This means that this box will not be able to go under this box. So this box has no option but to come alone, and the height it will be able to form is 2. Correct. I hope it is getting cleared. Don't worry, by the time we reach here, I promise you it will get cleared. 1, 2, 3. This is the box which we are treating as the box which will go under somebody. Let us see. Can this box go under this box? You can see I am having bigger width, good, but I am not having strictly greater length. No, I want strictly greater length. So I cannot go under this box. Let us try this box. Can I go under this box? Width is greater. I am having better width and I am having better height as well. So can I say this box which is making a height of 3, best height of 3, if I place this box under this, you can say this upper box, I'll be able to make a height of 4. This, the height of the upper box, the best of the height the upper box can make, plus my height is 4. Correct. I hope it is getting cleared. I hope it is getting clear. 4, 6, 4 and 5. Okay. For the case of 6, 4 and 5, we are just going to see that if 6, 4 and 5 acts as the bottom box, if 6, 4 and 5 acts as the bottom box, what can potentially be done? Let us look at all the boxes before us. We are standing on 6, 4 and 5. 1, 2, 3. Can 6, 4, 5 come below 1, 2, 3? You can of course imagine, just compare their widths. You can see I am having better width or like equal width. I am having a better width. That's what I want to have. This is what, like, I am having a better length as well. This means that 6, 4, 5 can go under, you can say 1, 2, 3. Okay, 4 is the best I have found so far. Let's try another boxes. Can 6, 4, 5 go under, you can say this particular box? Let's see. This is of course having a smaller base area. This means that is a potential candidate. Only thing we want to compare is I'm having a better width and I'm having a better height as well. This means that I can also come under this particular box. But am I having better length, better height than this, what I'm already having? No. It will not be updated. So this is the best of previous. You might recall this best of previous from longest decreasing subsequence. Best of previous. Right. The n square tabulation approach we discussed, that is exactly the same thing we are doing. 6 will now try that if I go under this box, what is the best I can do? If 6 goes under this box, it can go because the base area is greater, right? So let's see. Width, smaller. This box is having smaller width. Of course, the box I want to keep on top of me should have smaller width and length, right? Then only I can keep a box on top of me. I should have bigger length and width, correct? That's what I'm trying to say. 2 is smaller than L as well. This means that I am having both the things. But 3 is of course not better than what I'm already having. So what is the best 6, 4, 5 this box will be able to do? If 6, 4, 5 keeps this box and whatever boxes it keeps on top of them, it is able to make 4. And if this box goes under these all boxes, this 4, I'll be able to make a length of 10. Correct. I'll be able to make a height of 10. Okay. Let's look at the next box. This is the next box we are standing on. 746. If 746 is the box we are standing on, if 746 is the box we are standing on, what I'm going to do next? If 746 is the box I'm standing on, I'll try this box. Can 746 go under this box? You can see 4 is equal to 4. I'm not having a better width. I cannot choose this box. Let's try this box. 2, good. 3, good. So best of previous I've found so far is 4. Okay, let's try this box. 1, I'm having bigger width. 3, I'm having a bigger length. So I can of course treat this box as well, but it's able to make a length of 2, height of 2. So I don't want I'm already having a better height of 4 from this box, right? So let's try this box. I'm having a better width, I'm having a better length. Okay, this means that I can potentially choose this box, but 3 is not of course better than 4. So I will try to stay below this particular box, and if I stay below this particular box, this box was able to make a length of 4. And how was it able to make a length of 4? By going under this box, right? So if this box, this particular box is the box this person wants to go under, it is able to make a length of 4. And if I go under this box, I'll be able to make a length of 4, best of previous plus 7. I'll be able to make 11. Let's try next box. I hope that it is clear by now. So 4, 5, 4, 6, 5, 4, 6. What we're going to do? Let's try the previous box. Here, widths are equal and lengths are also equal. So I cannot do this. I cannot choose this one. Let's try this box. Widths are equal. I cannot choose this one as well. Let's choose this box. Width is small, like I am having better width, I am having larger length as well. This means that I can choose this box. Best of previous will become 4, right? It was not, of course, it was 0 earlier. It will become 4 for this particular box. Correct. Okay. Let's try this box now. I am having a better width. I am having a better length. I can choose this box as well, but why to choose this box? Because I'm already having a better one. It will also be able to, I'll also be able to come under this box, but I'm already having a better length. So if this is the box which I can come under, if this is the box which I can come under, I'll be able to make what the best this box is able to make plus my height. That's the maximum, like I'm trying to maximize my height. So 4 plus 5, I'll simply say 9 I'll be able to make. Let's talk about this box now. Quickly, let's, increase our speed a little bit quickly. So 6, 4 and 7 we are having. If 6, 4 and 7 I am having. 4, I'll try my previous boxes. I cannot go under this box. I cannot go under this box because of the widths. Widths are equal. I want strictly smaller widths of the boxes which are above me. I'm having equal widths. Can I choose this one? Yes, I can definitely choose this one. And of course, you can see that the best answer will be from this one only. It will be best of previous 4 only. 6 will definitely choose what? It will simply say that I'll be choosing, you can say I'll be choosing, yeah, I'll be choosing this 4 only and I'll be able to make a 10, right? 6 goes under the best of length 4, so I'll be able to make a 10. Let's try this box now. 4, 5, 6. This will get somewhat interesting. So can I go under this box? I am having a better, you can say width, but I am not having a better length. I cannot go under this box. I am having a better width, but I am not having a better length. I am having equal length. I don't want that. Better width, equal length. No. Better width and better length. So what are these people able to do? It's able to do 10. Okay. I'll store this 10 value here. Okay. Let's try the people before it. Better width, better length. What's the best I'm able to do? 4. So 4 will not be able to beat 10. Better width, better length. 2. I'll not be able to beat 10. Better width, better length. 3. I'll not be able to beat 10. This means that I can simply say that if 4, 5, 6 goes under this box, right? And of course, this box is able to do the maximum height of 10 if it keeps some boxes above it. 4, 5, 6 will able to do 14, right? Best of previous plus my height will be 14, correct? Let's try this now. So of course, if we try this box, best of previous will be reset it to 0. Let's try to find the best of previous for this particular box. 4, 6, 7. Okay, 4, 6, 7, 4, 6, 7. Let's try this box. Better width, better height. Okay, I'm having better width and better length both. So best of previous will be 14, and it is going to stay 14 only, right? Because even if I'm able to come above some other box, I'll definitely be able to have a better width and better, like I'll not be able to get better answer than 4, because 4 is the maximum you can see till now. So definitely you can, of course, a loop will be formed here. It will be checking for all the boxes, but this will stay the best one. So I'll write 18 here. And you can see the maximum height I'm able to gain is what? 18. It is 18, and 18 should be the answer for this test case. Let us try to get the expected output and see if 18 is 18 is indeed the best answer. So I have given this custom input, and this is the exact same input that we were discussing. 4, 6, 5, 1, 2, 3, 4, 5, 6. These were the boxes we were taking, and you can of course see the expected output is 18, right? I have done a dummy return to just check my you can say result itself. And yes, I hope the approach is clear to everybody. The first step, we are generating all the possible boxes. Second step, we are sorting those like generated boxes on the basis of their base area. And the third step, we are applying LIS, longest decreasing subsequence algorithm, which we learned in the last lectures, in the previous lectures. And I'm able to find the maximum height of the, you can say, box if I'll try to stack the box according to the given constraints, right? I hope it is clear to everybody. Let's get right into the code itself, and let's wind up this video itself. So now to write the code, you can say, of course, max height function they're giving us, height, width, and length arrays they're giving us, height of the ith box, width of the ith box, length of the ith box, like everything is in order itself. I'll create a class first, right? Of course, public static class box, right? And in this class box, I'll be having integer, you can say height, box will be having a height, box will be having a width, box will be having a length. Okay, all right. What I'm going to do now, let's write the constructor for this class, integer h, integer w, integer l, and I hope the screen is visible to you all. Let me zoom in a little bit, and yeah, I think it is. Just give me a second. I'll just change the font size itself. Okay. So box, this is created. So this dot h is equal to h. This dot w is equal to w. This dot l is equal to l. Correct. Okay. So I hope it is clear that I have created this class of box. Now what I'm going to do, I'm going to, according to the given types of boxes, they are giving me, I'm going to do what? I'm going to create an array list. I'm going to create an array list which will be of type box itself. So array list of box type ARR is equal to new array list. Correct. And I'm going to populate this array list by generating different types of boxes, right? So what I'm going to do here, so for integer I is equal to 0, I less than n, I plus plus, n is the variable they are of course giving us, right? So for every box I can create 3 configurations of that box. So I'll get the height of this box. Let's say I'll get the height of this box as height of I. I'll get the width of this box as width of I, length of this box as length of I. I hope it is clear. Height, width, and length I have extracted from these boxes. Now the next thing I'm going to do is basically uh, full focus. First configuration arr.add new box. According to the constructor, I have to pass on the height first, then width, and then length. So let's say height will act as the height for the first configuration h. Width will be math.min of, you can say, w comma l, remaining one, and you can say length will be math.max of w comma l. I hope this is clear. Now, right, I'm going to do what for the second configuration. Let's say you can say, I'll write of course the whole code, I'll not use any shortcuts. arr.add new box. Let's say in this particular box, height will be, let's say it will be length. I'll treat length as the height, right? Math.min, who will be the width? Min of the remaining one. width comma height are the remaining two people. Math dot max of width comma height will be the, you can say, height, you can say length of the people, right? I hope it is clear to everybody. Let us continue itself. I hope, yes, I've written the code correctly. ठीक है यार, okay. So arr dot add new box, the last configuration for this box. This time width will act as a height. For width, math dot min of remaining people. Who are remaining people? H and L, they are the remaining people. And math dot max of H and L for the length, correct? So maximum I'm trying to keep in length only, minimum I'm trying to keep in width only, right? And this is like, I hope this is clear that why we are doing so, to generate unique combinations of the boxes itself, right? So I hope this step one of generating boxes is clear to everybody. Let's move on to the next step itself. All right. So we have done the step one of generating the boxes. We are going to do the step two of sorting the boxes in terms of their, you can say, area, right? Base area. Now I'll simply write collections.sort arr, and I'll pass a lambda function here. Again, in the last class also I told you, if it is not clear, like if lambda function is not clear, you can of course tell me in the comment section. I can make a separate video on lambda function itself. So I'll simply pass here that, a comma b I'm going to pass here, and according to the lambda function I'm going to do what? I'm going to sort them in ascending order, right? If I want to sort them ascending order, I don't want to do a minus b, so I'll do what? Return a dot length into a dot width. This is the area of box A, minus b dot length into b dot width. I hope this is clear that how we're calculating the base area, and this step will of course sort all the boxes on the basis of the base area itself, right? Lambda functions are so easy. If it is not clear, of course tell me in the comment section. I'll be glad to make a video on that as well. Okay. So collection dot sort part is done. Step 2 is done. Now step 3 is simply LIS, correct? Now tell me one thing. After adding all these boxes, what will be the length of this array, this box array? For every, there are n total types of boxes, and for every boxes I'm adding 3 boxes in the ARR. So it will be 3n, right? So I'll simply say n, capital N is equal to 3 into, I think they are already giving us a capital N here, so they are giving me small n. So 3 into small n, right? I'll create a DP of length new int capital N, correct? And after doing this, after making this DP of length capital N, basically I'm going to do what? For integer I is equal to 0, I less than, you can say, capital N I plus plus, integer best of, for this particular box, best of previous, I'll initialize with previous, I'll initialize it with 0. And from the boxes before us, for integer j is equal to I minus 1, j greater than equal to 0, j minus minus. For the boxes before us, I want to choose those boxes who are having strictly smaller width, strictly smaller length. So let me, write something here. Integer my length is equal to, I can say arr dot get I of L, right? I'm getting the ith box in this boxes array, and I'm trying to get the length of this box. This is the my length. This is the box on which I'm standing on. Integer my width will be what? Arr dot get I comma W. Correct. I hope this is clear that how we are getting width and length of the boxes. Clear है जी. आगे बढ़ते हैं. So integer previous box length is equal to arr dot get j dot L, and integer previous box width is equal to arr dot get j dot W. I can only consider this box, I can only come under this box if previous length is strictly smaller than my length and previous width is strictly smaller than my width. Okay. If this is the case, then only I can come under this box. If I can come under this box, best of previous is equal to math dot max of what I'm already having as the best of previous, comma what? DP of j. What's the best this jth box, this previous box can do? All right, I have done this part. Let's now move forward. I'll simply do what? DP of I will be, my answer will become what? Best of previous boxes plus what? Arr dot get ith boxes height, my own height. And of course, in the last step, the maximum, this is the longest in the subsequence part. So maximum can lie in the any, we can say, index of the array. So integer max c is equal to 0. For integer I is equal to 0, I less than capital N I plus plus. You can say, I'll simply say max c is equal to math dot max of maxi comma dt of I, and will return max. And this will be indeed the whole code for this problem. Step by step we solve the problem. First step we sorted, like we generated all the different configurations of the boxes. Second step we sorted the boxes according to their base area. Third step, of course, we generated this DP array, and in the last step we did the, you can say, LIS thing, and of course the LIS answer can lie in any part of the array, and this is the whole solution for this problem. If the LIS part is not clear, of course you'll find an I button here, and of course you can try and solve the first LIS problem first. Of course this problem is having prerequisites, so you should definitely try to visit the prerequisites. You should try to watch the prerequisites first before getting right into this problem. So this is it for this problem. I hope you're enjoying the content, and if you are liking the content itself, you can of course support the channel itself by subscribing and liking the video itself. I would really appreciate your support if you can tell me in the comment section if you are enjoying the videos or not, your feedback or whatever, right? So this is it for today's lecture. Thanks a lot everybody for joining. Until the next video.